All right, hello and welcome. Welcome to everyone watching this session live or perhaps a recorded version on YouTube or any other channel. Thank you very much for joining us today for this session, LinkedIn Live session on this topic of role of IOLink in digitalization. My name is Anand Taparia. I take care of marketing here at Utthunga, which means me and my team we sort of take the word out to the rest of the world in terms of our product engineering capabilities. Utthunga is an industrial product engineering and services company located out of Bangalore. It's our effort to bring in thought leaders from the industrial community, and as part of that, we've been doing variety of topics over the past few months. In the same sequence, today we have Frank Moritz from SICK AG talking about graciously making his time available to share his thoughts on this topic of, role of IOLink in digitalization. I'll of course hand over to Frank to introduce himself more. Just briefly about Frank. His, of course, as I mentioned, from the renowned company SICK AG, where he's the technical industry manager for industrial communications. In the IOLink community, Frank heads the IOLink technology and the IOLink quality working groups, including working groups at some of the other Fieldbus consortiums. I can speak a lot. He has 20 years of experience in the in the Fieldbus communications and connectivity area, a member of the IOLink steering committee, and also since 2020, a member of the PNO board, the PROFIBUS board. Frank, just quickly, wanted to just give it to you to, if you could introduce yourself before we dive into this short session. A lot of questions to ask you. So yeah, over to you.
Here, so thank you, Anna. Yes, I think you have already said most of all. So I have a long experience with IOLink. More than 15 years ago, we started with that, and I was part of this foundation area there. And yes, it's up to now. I'm very close to the IOLink community in the steering committee, and also responsible for the technical things and also for quality. And yes, I like to be here for your event here and talk about the role of IOLink in digitalization. So,
Yeah. Thanks, Frank. I mean, I'm sure we're going to pack a lot of questions in this 30 minutes. So almost like a capsule for people listening in to really get a high level sense of IOLink. But I'm sure, if given time, we could spend an entire day or more, just on this topic. So before we dive in, just quick housekeeping points. As always, this is getting perhaps a routine for me, people who've been listening to these sessions. It's a 30-minute session. We've spent a few minutes right now, and towards the end, we'll spend another 5 to 7 minutes for questions and answers from people who've tuned in. Please post your questions to the comments section, to the comments bar in your LinkedIn page. And in between 20 minutes, I'll try to not necessarily rush through, but try to ask as many relevant questions to Frank so that we are, all of you joining in, walk out with a decent understanding of IOLink and the role IOLink plays in digitalization. So let's dive in, Frank.
okay.
So, of course, the first question and the obvious question, is what is IOLink? There's so many protocols that exist. So, some maybe people may be thinking, why one more protocol? Of course, it's been in the industry for a while. And if you could cover this from the aspect of what are some of the areas that IOLink addresses, which other protocols don't? And before you get into that, because you of course represent, the broader umbrella of PI here, if you could start with a few words, about the IOLink community, and then of course, try to answer for the audience, what is IOLink?
Okay, yeah. So starting with the IOLink community, and I want to say the success story of IOLink. You can see here, it's the number of nodes over the years and nodes are master ports and also devices. And you see that the story roughly began somehow 2010, 2011. And then we get a ramp up and increasing nodes. And today we have 27 million nodes in the market, and that is a huge node number. But what's more important is behind that are more than 7,000 different IO-Link devices and 20,000 variants. So this is the perspective from the pure numbers, but the community itself is a very active community. It's the IO-Link community hosted by PNO. But IO-Link community is acting very neutral, very acting by themselves. And up to now, we are really proud to have a membership number of 416 companies in the world. So before 10 years, it started maybe in Germany, Europe, then it goes over to US and also in Asia and in China and Japan. There are a lot of new members. So this is a really success story. And the community itself is also very active. We have different working groups, also for profiles, for quality, for marketing. And I guess that more than 50 people are working on a regular basis within this community.
Okay,
Yeah.
so from the perspective of the protocol as such, in terms of the features or the data types, the various type of data that IO-Link supports, and some of the ease of configuration, anything on those aspects, for people who perhaps just connect.
Yes. So one of the questions is and was why IO-Link? And you mentioned before that there are a lot of bus systems in the world. So where was the room for IO-Link? And what we can see here is that IO-Link is, I want to say, below the field buses. So IO-Link itself is not a bus. It's a point-to-point communication protocol. It's not that really fast. It provides cycle times of, let's say, roughly 2 milliseconds or 1 millisecond, 2 milliseconds. And it's not a bus. And that was one of the successful stories or factors for IO-Link, because implementing a field bus into a very small device, which maybe has dimensions of 5 millimeters or something like that, this doesn't fit. So on the other hand, there was a need on the sensor side, and if I say sensors, also on the small actuator side, to communicate, because these devices get more and more intelligent, have microcontrollers on board, and have a lot of data on board. And the goal was to bring this data from the lowest end of the automational pyramid up to the PLC or up to the upper layer systems. And there was an absolutely need that this communication path has to be easy. It has to have a small footprint. It has costs far below the ones if you implement a field bus node. So that was the goals for IO-Link. And yes, then it started roughly 10 years ago, and with implementation of let's say IO-Link protocol on a standard wiring, another success story. No special bus cables, nothing special there. Just use the sensor actor cables, which are standardized in the world today, using an M12 or M8 connector, and run this easy protocol over that. So that is IO-Link basically, and what we can do with that interface now, and that was a question as well. What are the functionalities of this? Well, we can transport or exchange process data, let's say 1 milliseconds, 2 milliseconds cycle time, but also we can do parameterization, we can do diagnostics, we can do the so-called condition monitoring of sensors. And this is the feature set or the benefit set of IO-Link. And if it comes to the question, where is IO-Link used, then one of the answers is mainly, and there we started, is the industry of factory automation. So let's say IO-Link was started for needs in factory automation, which means we have a length restriction of 20 meters and a cycle time of 2 milliseconds, which fits perfectly to machines. Yes, and if we dive a little bit deeper in what is factory automation, then I want to say it's the broadband of all machine types. One of them which came in my mind are packaging machines. They started earliest with using this IO-Link interface and with some proximities, which is at the end. Another area now IO-Link is gaining more importance is also on robot applications. And if I talk about robot, I mean not the robot itself, but the end of arm tooling of robots. So you have to imagine that the robot has some tooling, and on the tooling are actuators and sensors, and of course they have to communicate. So and therefore IO-Link, especially IO-Link wireless, we will see later, fits perfectly to that.
Great, great. I mean, you've covered the fundamentals, and of course, I don't intend to go too core or too basic. I mean, a lot of people may be aware of it, and in fact, ILink consortium itself has put out a lot of material out there for people to consume. Let me kind of touch upon and ask your thoughts, views on one of the very perhaps popular aspects of IO-Link in terms of how it eases device replacement and maintenance
Yes.
because of the data storage and localization function. So if you want to talk a little bit about that.
So while developing IO-Link as a communication interface, there was also some features implemented, what I call more or less features or applications of IO-Link devices. And one of the features is the so-called data storage mechanism, which means if you have the need to replace a broken device, just unplug it and replug it again to the IO-Link master, and the IO-Link master itself has all the data stored, which he can write down to the device, and the device is up and running, let's say 2 or 3 seconds after exchange. Everything is perfect. You don't have to do manual button pressing or using an external software or something like that. It's just plug it, change and produce, I want to say. And this is a great feature of IO-Link.
Yeah, yeah. Great, great. I mean, yeah. Let me now move on to perhaps the most important question of today in terms of the topic of the session, which is the role of IO-Link in digitalization, and especially it exists at the sensor actuator level layer. If you look at the IC95 pyramid and connects those to the layers above the controllers and everything else. So as the enabler of digitalization of the last mile. Just want to hear your thoughts. What about IO-Link, or how does IO-Link really play a significant role in digitalization? And perhaps you could touch upon, it enabling as a gateway to field buses and controllers. So, just your thoughts on that, Frank.
Yeah. So as I mentioned before, yes, we are with the IO-Link sensors and actuators at the very low end of the automation pyramid. And if it comes to digitalization, then it is meant that data are generated, right? But they should also be transported over the different layers, maybe up to a cloud service or maybe up to PLC or something like that. And there comes the role of IO-Link, that there has to be, or there is used a so-called IO-Link master, converting the IO-Link data and the whole bunch of data, is it diagnostics or is it parameterization, doesn't matter, is mapping these data to the field buses. And if I talk to IO-Link, I have to say it's not the only or one field bus. So we have adaptations to the most relevant field buses. If this is PROFINET, is this Ethernet IP, if this EtherCAT. So you can bring all the data to the field bus level and use it in the PLC for digitalization purposes. On the other hand, there is another technology running in parallel, means if you have a field bus interface on the IO-Link master, you can, or there's very often also implemented a standard Ethernet interface, and therefore running OPC UA data if a OPC UA server is built in, or what's also very common, a REST API, which transport IT well-known JSON objects. And with that way, everything is open to bring the data from the very lower end to the upper end, to the world, to the internet, to the cloud service, for any reason or any purpose you want to use it in terms of digitalization.
Okay. Now, there's one concept, of course, perhaps of relevance right now, and people want to hear also the IODD files and the parameterization. If you talk a little bit about that.
Mm-hmm. Well, that is a key factor of IO-Link. That the IO-Link device is one thing, but there is also a very powerful device description. And if you know PROFINET, you may know GSDML. So IODD is something similar, but more powerful than the GSDML. So the IODD itself is covering everything what's regarding the parameters and the data objects of an IO-Link sensor. And if it is possible that let's say a PLC or engineering tool to import this IODD and interpret this IODD, then it is possible to talk to the devices really by names, and you get a real number back, rather than talking to some index and sub-index and get some bytes back. So it is very comfortable for integration purposes, and therefore using the IODD, you can also build on a PLC side automatically function blocks, just talking in a I want to say convenient, human usable way to the IO-Link devices. And on top on that I want to mention a special service or database which is run by our Link community. It's called the IoT Finder. And the IoT Finder itself contains, as I mentioned before, more than 7,000 different devices and 20,000 variants of it. But the best on this IoT Finder are two things. One thing is that it has a machine-readable interface, so that, let's say, a PLC or engineering tool can automatically detect which device is connected and then download from the database the right EODD, and also then interpret and maybe setting up a function block talking to these devices. The other thing is a very new one, which also was built in the IoT Finder, is that people can click on a device and just not downloading the IODD, they can start the IODD viewer and get in a really human readable way seeing all the parameters there. I think it's better than reading the data sheet of a sensor. So it's very convenient and comfortable to use. So that is what makes IO-Link easy usable.
I've got plenty of questions, and I'm just looking at the time, so I'm going to shift gears, Frank, now, and two very important questions that I want to ask, this one now and the one next. So, from an OEM perspective, the companies building IO-Link based products, what should OEMs who are building IO-Link products be aware of? So, we have the masters, we have the devices, the slaves. So, if you can touch upon, what should they be aware of as they are building, and perhaps, from a slave aspect, if you look at the footprint of the device, IO-Link's role in that, or the auto detect functionality of masters, and just a wide variety, as much as you want to cover, in the time we have.
Okay, so if vendors want to build IO-Link devices like sensors, actuators, or even masters, so there is to say that everything is prepared. So we have a good landscape of specifications on it, defining the communication itself and also the basic features like data storage. And as a recommendation, I want to say just use the latest specification set, which is package 2020 called. And everything what's in documentation is in there. You can use to build an IO-Link device. And if it comes to testing your device and doing the manufacturer declaration at the end, there are two testing tools available in the world. They are commercial testing tools, and you can buy it and can test all the functionality which you can build in the device. I want to say that is all what you have to mention or building a device. On the other hand, on the master side, it's maybe a little bit more difficult because there you have to decide if you build a master. First of all, how many ports do you want to build in? Usually are 4 to 8 ports, but I have also seen 2 or 16 ports. But how many ports do you want to build in? And which type of ports? There are 2 types of ports called Class A and Class B. Class B is with an extra external power for actuators. So that is the challenge a master provider has to solve to answer these questions.
Okay.
And additional to that, okay, we have on the upper side of the IO-Link master a field bus, maybe 2 field buses. So some are running 2 in parallel, or the JSON REST API interface, which can be used to bring the data, let's say, to the IT world. So manufacturers of masters have to decide which of these interfaces they will build in. And if they decided to build in, then the answer is an easy one. Just take the mapping specification, which exists also for Profinet or also for the JSON REST interface, where everything is described, how this will work and how to what will be implemented there.
Okay. Now, are there certain challenges that the vendor should be aware of? Look, like you mentioned, it's not a fast protocol, you mentioned earlier, and it may not be suitable for motion control or high-speed applications. Or, given it cannot really process, large amounts of data, 32-byte limit. So any constraints that, vendors just need to
Well,
know
yeah,
of?
yes, you're right. So it is, let's say, a small footprint or low cost or economic cost interface. And therefore, it's not a bus, it's a point-to-point communication, and it's limited in two things. One is the speed, which means it's 1 to 2 milliseconds cycle time, which answers your questions. This is not an interface for isochronous real-time and real drive connections. And it was never intended to cover that area. And on the other hand, there is another restriction, which means 20 meters. So this is a limitation we are often faced in the past for logistic automations or also process automations, where usually you have longer distances. But that's the only two restrictions IO-Link has. I can't remember that there are others. So if it comes to the data itself, it's so comfortable for all the data and functionalities you need that there are no limits to use IO-Link.
Okay. Okay. Let me now ask the question from the other side. From the we've spoken about the OEM community building the products. Now, what should industries, users adopting IO-Link, products should be aware of?
Mm-hmm.
And perhaps what is, a basic question could be, what's the basis to choose a product, a master device, the sensor actuator?
Yeah, so that is an easy answer, I think. So if you are a machine builder or something like that and want to use IO-Link, then you have to choose, first of all, the right sensor for your application. And I'm pretty sure there are the right sensors on the market. As mentioned before, 7,000 different things, also lamps and actuators and valves and proximities, which is so nearly everything you need as a machine builder, you can buy by IO-Link. And if you do that, the next step is how to connect this. So therefore, you have to select an IO-Link master. And therefore, also a lot of different IO-Link masters are on the market. In IP20 cabinet versions are there available, or IP67 field devices. But what you should see there is, again, how many ports should the IO-Link master have, and to which upper layer field bus system or Ethernet communication system shall this data apply. So these are the only things. And maybe another comment on manufacturer can have is on the system itself. So if it's let's say a PLC system based on Profinet or something like that, then he can ask also the system supplier getting the functions blocks, which very convenient drive the data out of the PLC down to the devices. And I want to say that is all.
Yeah. Great, great. I mean, you've already spoken about a lot of things. You spoke about the physical limitations of distance or speed. Anything on the power supply part, Frank? I know.
Yes. So coming to the power supply, there are, I don't want to say restrictions really, because in former days, devices power supply was limited to 200 milliamps. Since the latest version of the specification, it is open. So devices can also consume power of current up to 4 amps. Depends on the amp-earth connector. There is a limitation there. But well, on the master side, vendors have to check, or machine builders have to check, if the master is providing this power which device really needs. So up to 200 milliamps, everything is okay, no problem, plug and play. If a device has a consumption of 2 amps, you have to check if the IO-Link master port provides this 2 amps. So that is all.
That is all. Great, great, fantastic. Well, I want to squeeze in questions also, and I know I have 5 minutes, but I just want to kind of pick your brain quickly, on the roadmap for IOLink, and perhaps at least you could perhaps cover broadly the two things that come to my mind is from the IOLink safety perspective and IOLink wireless. If you could at least touch upon these and more, if you want, the
Yeah.
roadmap for IOLink.
Yes, what's on the roadmap? Yes. So we started with the IO-Link wired version now 10 years or more ago. And what we have new in the technology portfolio is one thing, it's the IO-Link wireless, as you see here on the picture, which is also technology bringing cyclic data in the range of 5 milliseconds from, let's say in this case, a tooling of a robot to an IO-Link master and then wired to a PLC. So this interface is very useful, providing or transmitting process data as well as transmitting all the other data like diagnostic data and parameters. And the big feature is there that it is reduced the cabling or reduction of the complexity of the adapters of such a robot arm. Yeah? So this is one technology which is on the roadmap. The other one you mentioned before is IO-Link safety. And I can say IO-Link safety is now ready and will start beginning next year. So everything is tested and certification is clear. And I know that some companies already are producing IO-Link safety masters as well as IO-Link safety devices.
And it's on the same three wires, right? The safety.
Yes. It's on the same three wires, and it's just let's say a protocol like a ProfiSafe on ProfiNet. It's an IO-Link safety protocol on IO-Link. And but one last comment, and what we have also on the roadmap in the early stage is that IO-Link wants to go on the single pair Ethernet physical layer, which has only two wires. And IO-Link will use this single pair Ethernet as a point-to-point communication again, and only use it as an additional physical layer, overcoming the limits of 20 meters and the speed of 2 milliseconds. So this is also on the roadmap, and working groups are working on that.
Wow, wow, I didn't know much about that. Wow, that's fantastic. That's great to know. Well, I probably am just going to jump and jump to questions from audience because we really do not have time. So let me check what sort of questions we have at this point. Okay, one, Frank, is IOLink intrinsically safe?
No. As I mentioned before, IO-Link was designed for factory automation, not for process automation, and therefore it's not intrinsically safe. But if I look to the future and I talk about single pair Ethernet as a physical layer, you know that APL is also single pair Ethernet layer, and that one is intrinsically safe. And I can imagine that we can use this physical layer of APL and running IO-Link data over that. Then there would be an intrinsically safe IO-Link, maybe in the future.
Future. Got it. Got it. You touched upon this quite a few times, and I think the question is sort of connected. And I have two questions. I'm just going to combine them. Uh, how different is IOLink from a field bus? What does it mean that IOLink is field bus independent? So,
Yes. First of all, the difference of IO-Link and a field bus is that IO-Link is really point-to-point communication. You have one IO-Link master port connected to via one IO-Link device. So usually for a bus, you have connected more than one device on the bus. That's the main difference. If I say it's neutral to field buses, then I have to go a little bit back in history and saying, yes, we have in history the field buses. Let's say we have a Profinet, we have an EtherCAT, we have an Ethernet IP. And each of these field buses tried to establish a small or small footprint communication below that to the sensors and actuators. But they are driving for the Profinet world, the Profi data model, for the Ethernet IP, the SIP model. And what IO-Link does is going the other way around. So IO-Link has defined its own protocol, its own data information model. And this is adapted or could be adapted to all other field buses by the IO-Link master. And there are solutions for Profinet, there are solutions for EtherCAT, there are solutions for Ethernet API and some others. So IO-Link you can adapt due to its neutrality to all these different field buses.
Yeah.
That makes it very universal.
And hence I guess that's a fantastic point to end on, because the whole idea of the role in digitalization, the universality of the universal appeal of it, really makes it a great enabler for digitalization. So I'm afraid that's all the time we have and cannot take any more questions. Feel free to please reach us on our LinkedIn page. I'm sure we'll have Frank answer those subsequently. Thank you. While just wrapping this up, thank you everybody for tuning in. I hope this brief session, we really try to pack in a lot, and it's not possible to do justice to a topic like IO-Link in this short span of time. But I hope you got a high level overview of this very popular and very aggressively being adopted protocol. Request you all to please follow us, Utthunga, on our LinkedIn page and also on our YouTube channel. Information on sessions like these from thought leaders like Frank and other people we've had over the past months and also planned. We post that information on our LinkedIn page. We have one actually coming up on Ethernet APL, another topic that Frank touched upon. We had up on SPE also a couple of weeks back. In fact, yeah, just last week or a few weeks ago. The date for that is not decided yet. We will post it on our LinkedIn page shortly. So I just request you to please follow us there so you'll get all the latest news and information there. So, before I just want to hand over to Frank to sort of close this session, his closing thoughts. But I just want to formally thank you, Frank, for your time and sharing your valuable insights. Just before we close, final thoughts and comments about IO-Link or the community or the PI, umbrella, anything you want to talk about. Just last few words from you.
Yes, so in general, my last words is IO-Link is a really well-established, robust technology, and you never fail if you use this in your machine design. That's what I want to say. So IO-Link is universal, smart, and easy. And
And
it is.
I know you don't say that as a marketing buzz sentence, but it's proven itself. We as a product engineering company, we see a lot of interest from the vendors out there trying to build IO-Link products. So we can also vouch for it. But you probably see it there, day in day out, and it's proven it over the years. And IO-Link wireless and IO-Link safety that you're talking about. So and the SP version, the APL versions, hopefully in the future, future-proof technology from some aspects. Thank you so much, Frank, for your time. Appreciate it. And thank you, everyone, for joining us for this short session. Take care. Have a good rest of the day, evening, wherever you might be. Bye-bye.
Bye-bye.